Hello children and welcome to the session today. Children, we have learned about many scientific concepts over the years that we have been learning science. Today we are going to understand a very important concept from chapter number 4 of your book, Heat and its Effects. So we all know that when the temperature becomes very hot, we switch on the air conditioners. So when there is heat outside, we counter it with the use of air conditioners. And in winters, when the climate outside is very cold, what do? We switch on the heaters. So a normal amount of heat is important for all of us. But what happens if the heat increases? What happens when heat is transferred from one object to another? These are some of the topics that we are going to cover in this chapter. We are going to learn how heat brings about a change in the state of matter, effects of heat, thermal expansion in solids, liquids and gases, and temperature and its measurement. So children, to begin the chapter, let us quickly recall the three different states of matter. So if you remember, this is how the molecules in a solid look like, right? So the first state of matter is solids. Next, the state of matter that we have learned is liquid. So in a liquid, the molecules are loosely placed, right? The third state of matter that we have learned is gases. So as we can see, solids, the molecules are very closely packed. There is no scope of movement. In liquids, there is a lot of scope for movement, and in gases, there is a lot of scope of movement. So the first thing we need to understand is that heating brings a change in the states of matter. So when a solid is heated, what happens? Here an experiment is given, a very simple experiment is given in your book, which tells us what happens when ice is heated. So when ice is heated, which is solid, it converts into water, which is liquid, and when water is further heated, it begins to rise as water vapor. So on heating, water from the form of solid ice changes into liquid water, then finally to liquid vapor. And if we want to go in the reverse direction, what do we have to do? We have to cool them. So here what is happening? Can you guess? So when you are heating the solid, the molecules are moving apart. When they are moving apart, a change of state is taking place. Solid is becoming a liquid. Again in liquid, what is happening? If you continue heating it, the molecules will move further apart. And when this happens, the state of matter changes from liquid to gases. So what is heating actually doing? Heating is changing the state of matter. It is increasing the distance between the molecules. So children, this is a physical change that is taking place because we can reverse it. Now what happens when heating causes a chemical change? As given in your book, this beautiful example tells us how heating brings about a chemical change. So in a test tube, you take copper sulfate. Of course, this experiment has to be done under adult supervision only. When you heat this copper sulfate, which is blue in color, you will see a change of color that is taking place. Blue changes into a totally new color. So what is this? This is a chemical change. So children, what does heating actually do? Heating brings about a physical change and heating brings about a chemical change. Now let us understand the effect of heating in different states of matter. For example, let us understand how thermal expansion takes place. So what does the word thermal mean? The word thermal means related to heat. So what will be the meaning of thermal expansion? Thermal expansion will mean expansion because of heat. So here what is happening? As we have seen in the states of matter, the molecules, they were spreading apart. So when the molecules are spreading apart, what is going to happen to a solid? It is going to increase in size. How is it going to increase in size? We can see with the help of this experiment here given in your book. So in this experiment, they ask you to take a metal ball. Now here in stage number A, before heating at room temperature, the metal ball passes through the ring. It is at room temperature. But if you heat the metal ball, it gets stuck in the ring. Why does this happen? Because when you heat it, it expands. It increases in size, right? So this is what heating does to solids. Now let us understand what heating does to liquids. So in another experiment in your book, we can see that they have taken a round bottomed flask, as we can see in this picture here, and they have fixed a rubber cork and they have attached a tube that comes out of the rubber cork. Now if you see very carefully here in this picture, this is before heating. So before heating, what is happening? We can see that the amount of water that is rising in this tube is very little. After heating, we can see the amount of water reaching actually to the tip of the tube. So what is happening on heating? The liquid is expanding. So if you have ever noticed milk boiling over at home, why is it happening? Because milk is expanding due to the heat. Now let us understand how expansion in gases takes place. So gases, as we had studied on page number 1, the structure of molecules in gases is already like this. They are way apart. So what is happening here when the gas will be heated? What will happen? Because they are already so distant from each other, these molecules will want to just run away. And how can you prove this? A very easy experiment where you take a balloon and fill it with air and keep it outside in the sun. What will you see? The balloon will continue to increase in size because the gas inside the balloon is expanding as a result of the heat of the sun. And eventually what will happen? The balloon will burst. Next, what are the examples of thermal expansion around us? So there has to be some use of thermal expansion in our lives, right? So there are two things which are very, very important and you see them everywhere. One is an electric kettle and the other one is an electric iron. So when you are using these two things, what is happening? After they reach a certain temperature, they automatically get switched off. Why do you think that happens? So, my guess will be maybe because it is to avoid overheating. Yes, it is correct. But what is placed inside these two electric devices that cuts the current off, that stops the iron from heating further? It is called a bimetallic strip. As you can see in this diagram, this bimetallic strip helps to maintain this contact. Because of this contact, the object, the iron or the kettle continues to heat. But when it is overheated, what happens? This bimetallic strip bends and as you can see here, the contact breaks. So when the contact breaks, the circuit breaks and the iron or the kettle are automatically switched off. Imagine if this wouldn't happen, what is going to be the result? The kettle, they are going to continuously get heated up and they are going to burn out. So these are some examples of thermal expansion in our daily life. Also take a look at this railway line. So if you've ever traveled by train and seen railway tracks, you will see that there will be gaps between the railway tracks. Why are these gaps given? These gaps are given so that in extreme heat, when the metal expands, if there are going to be no gaps, what is going to happen? These are going to bend. Similar is the case in the beams that are used in bridges. These beams also have scope for expansion and So is the case of electric wires. These electric wires, they contract when it is cold and they expand when it is hot. So that is the reason this gap has to be given. These cables are let loose. Whenever you see poles that have electrical wires in them, they are never going to be like this. How are they going to be? They are going to be like this, so that they can expand and they can contract due to the heat. So when this heating is taking place, when this expansion of molecules is taking place, what else is happening inside the object? The temperature is rising, right? So we all have had fever once or twice in our lives and we know what high temperature feels like. But what exactly is this temperature? Let us understand through this video. Temperature is the degree of hotness or coldness of an object on some chosen scale. A thermometer is used to measure temperature. When you have fever, your mother uses a clinical thermometer to measure your body temperature. It can measure temperature from 35 degrees centigrade to 42 degrees centigrade. The mercury present in the thermometer enables us to know the body temperature. The normal body temperature is 37 degrees centigrade. How do we measure the temperature of other objects? A laboratory thermometer is used to measure the temperature of substances in the laboratory. The range of laboratory thermometer is -10 degree to 110 degrees centigrade. You can measure the temperature of hot water using a laboratory thermometer. Suspend a laboratory thermometer from an iron stand. Place a beaker with hot water under the thermometer such that its bulb dips completely in water but does not touch the base and sides of the beaker. You will notice that mercury in the bulb rises up in the capillary tube on gaining heat. The mercury thread stops rising once the temperature of the mercury becomes equal to that of hot water. Carefully read the temperature from the scale at which the mercury thread stands. This will give you the temperature of hot water in beaker. For example, the temperature of hot water shown in the thermometer is 80 degrees centigrade. If you remove the thermometer from the hot water, the level of mercury starts falling. It is thus clear that the temperature of hot water must be read while the thermometer is in hot water. So now we understand what is the use of a temperature. Now it is important to understand that there are two scales, the Celsius scale and the Fahrenheit scale. In the Celsius scale, 0 degree is the lowest temperature and 100 degree is the temperature of boiling water. Whereas in Fahrenheit scale, the lower fixed point is 32 degree Fahrenheit, which is the freezing point of water, and 212 degree Fahrenheit, which is the boiling point of water. So there are two kinds of thermometers. One is the clinical thermometer and the other is the laboratory thermometer. If you look at the picture very carefully, you will realize that both these thermometers look practically the same. They have got a bulb in the front. They have got mercury filled in them. When the temperature rises, the mercury moves up. It shows you the temperature. This is a laboratory thermometer and this is a clinical thermometer. Again, in this case, you can see that there is a bulb and there is mercury. The difference between the clinical and laboratory thermometer is that the end of the mercury, there is a kink. What does this kink do? When you are measuring temperature by putting the thermometer in your mouth, if you take it out, the mercury should stay and tell you that this is your body temperature. That kink prevents mercury from falling back. Children, nowadays you may not have seen mercury thermometers. The reason is this mercury is very dangerous if it comes in contact with the body. So now there are digital thermometers which are shaped exactly like the clinical thermometer. There are also these forehead thermometers that you can just place on the forehead and get the temperature. And we all have seen during COVID times, the development of infrared temperatures with just a click near your forehead or your palm, they can tell the body temperature. So children, some of the precautions that we should take while using digital or clinical thermometers are, as I said, mercury in these thermometers is very toxic, so we have to handle them with a lot of care. We have to understand that while measuring the temperature, the bulb of the thermometer should be completely in contact with the object or the body. A laboratory thermometer can only be used in an upright position because there is no kink. The moment you tilt the thermometer, the mercury is going to change its position. Thermometers must always be washed before using, and while reading the temperature on the thermometer, the mercury of the thermometer should always be at the level of the eye. So children, in this chapter we have learned how heat affects the different kinds of matter, the different states of matter, solids, liquids and gases. We've also understood how temperature changes in different cases and how temperature is measured. Hope you are ready to delve into the question and answer session. Thank you.